Okay,
Cool.
go ahead.
All right, let me share my screen. Share screen, here we go. Cool. All right, so hello, I'm gonna talk about my we'll just edit this out. We'll do it in post-production. It's all good.
No, we will not edit the hello. Go ahead.
So I worked on this project, MonitauR, with a terrible name, like a year ago. It was sort of my attempt to build a package in R. And so recently just added a couple extra features to this. So I thought I might talk about it. So basically, this is a package that allows you to monitor the progress of your R scripts using a special comment syntax. So this is something that's actually done reasonably often in R, where they build these sort of domain specific languages on top of R. So there's a couple of different other packages that use this same sort of, I guess it's kind of like a hack, where they will have a comment with some other special character after it. And this actually defines some sort of code or some way that the script is parsed and processed. So this happens with Roxygen and Plumber. And I'll go through them in a little bit, but yeah, basically this is what a MonitauR script looks like. Has these little comments, and then these comments are used to basically log your progress through a script. So you go from this sort of script into this. So it has a web app that basically you can go to this website and it will show you the progress of your script in real time, which may be useful. I don't know. I was just doing a thing. So I have a small demo. Can you guys see this R thing? Yeah, okay, cool. Yes. So here's that script here. I've changed it slightly. This is just a different way to run it, where you can put this monitor script. And I have a couple of things here. So I have a name for the script, which I'm calling square script, and a token. And so this token just allows me to group together scripts and in the web app. So this is the web app on the side here, and I can just type in. So when you start, you can just enter a token here. Key is broken. Cool. So if I just source this script, it sets this initialized. You end up with this initialized. You get a URL to go to. It does this thing. It tells you what it's logged. So it hit that, computing the square, setting up the square function, and then computing the square, and then it finished. And then you can see on here, while I was doing that, this sort of popped up, and that sort of shows you the progress during the thing. So that was a pretty quick script. So I'll do one. This is a sleeping script, so it goes a bit longer. So basically it just goes through and it sleeps for various increasing times and just has these comments saying how long it's sleeping for. Same sort of thing. It's using this codar token. So hopefully that works. So yeah, so it appears there and it has this little running thing. So I can click on that. And then here you can see they're running on that side. And as the progress goes through the script as it's sleeping, it sort of updates on this web app. So yeah, that's sort of the basic idea. You can, if you have some long running script or a bunch of different scripts, you can add this to it, name them, and sort of monitor the progress. It also captures errors. So here's another one here that has a script that, I don't know, just does something dumb. I'm not even sure what it's doing, but it just makes an error. So if I type in error, and then yeah, so it gets this error, paragraph.data no such file, and then so this comes up and it says there was an error in this error script, and then yeah, cannot open the connection. So that's that file connection error. So that's basically what it does. yeah, you can monitor your scripts. So that was a quick demo. Why did I do this? There is, like in a lot of other languages, this is possible. There generally are these like frameworks and stuff available to do monitoring. One of the pretty common ones is Rollbar, I think it's called. And it's basically just like, they're just things that you add to your script that just say like, okay, I wanted to monitor this script. Sometimes you can sort of do more complicated stuff about like CPU usage and things like that, but I haven't really done any of that. With this, yeah, I like to make RESTful web API. So there is a RESTful web API built into this. And yeah, it was just sort of a starting point because I wanted to build a package in R. I already had some of the theory and understanding of how to do that. And then, yeah, I'm trying to learn more R. So that's a good thing. So I gave a talk a while ago called Exposing Your R on the Web. And that was sort of using this package, Plumber. And so Plumber allows you to generate APIs, basically. So these are application program interfaces, and a web API is this one that's exposed on the web. And so it allows computer programs to talk to each other, basically using some protocol. In this case, HTTP requests. And so this file here is what an Plumber application sort of looks like. And basically you would just have some function and you can decorate it. So this is that same sort of hacky comment syntax. So this, if you run this as an R like function, as an R file, like if you source this file just normally, nothing would happen. These comments are just ignored, obviously. But when you use Plumber to source it, it intercepts these special comments and then sets up the file to create basically a web server. And so that web server, this sort of defines how that web server works. And it has these like, this is saying a get, so a get request is a type of HTTP request. It's like the most common one when you just go to a website. And so if you go to this like URL endpoint echo, it will basically run this function that's underneath this sort of decorator code. So yeah, it's sort of like a little hack on top of R. And I wanted to use this, and this sort of gave me the idea of using those special comment syntax to do the logging. Yeah, so this is like, I've also seen the special comment syntax in Roxygen, which is like how you do documentation for R code. So you can write up these sort of like hash, comma thing, apostrophe, where you can document your code. And this is how R packages auto-generate their documentation using Roxygen. So you can have this sort of style syntax above your code. So this doesn't run or anything, but when you pass the file with Roxygen, then this code is evaluated. So yeah, they kind of feel like hacks. They're written on top of the language. You might call them like a domain specific language, where you take a language like R and you write some other language on top of it to make it work. Like to do a specific domain function. So in this case, write documentation. Yeah, and so with MonitauR, as we saw, you use the similar comment syntax with those like hash, less than sign, and yeah, you can run it in different ways. So you can use this, you can call a script by passing it to MonitauR, and that will like pass these special comments and then evaluate the script. Or you can, like I did in the other examples, where is it? Yeah, you can just add it to the top of your script. And so if you just run the script normally, it will then log the code. So yeah, basically there's like a little bit of a life cycle to this project. So the script, so when you pass it here in like this thing and you say, go to this example square script, the script is like read and all the expressions are extracted. So each like code block within the file is extracted. And then a job ID and a token is generated. And so basically it contacts the server and says, I want to initiate a job. And then that ID that the server returns is used for all the future logging steps. And then the job status, so it sends another request to the server and sets the job status to running. And that's when it was like that little blue circle. And then the script is evaluated. So basically the script then just proceeds in the normal sense. But so did I skip this out? But basically, yeah, when it gets to these futures, and I'll go into this, I guess, where this is basically setting up code that will run later on. So it can get to these futures and then they're run. So basically it just turns those comments into requests that say log this particular step. And it does all this in a big like try catch loop. So if there's an error, it catches that error and then it sends that error status to the server. And then when the job completes, it sets the status to finished, which is how you get those green ticks. So yeah, this is sort of like the overall project architecture. So it's actually 3 different projects. So there is MonitauR, the one that you use in R. There's a web, there's this API, which is running on a Heroku server. And so Heroku is like an infrastructure platform, basically, where you can deploy applications, kind of like Google Cloud or Amazon AWS. But theirs is sort of much more curated. So it's very easy to deploy stuff to Heroku. And so this web API has a Postgres database, which is also deployed on Heroku and uses the database interface package and DB plier to read and write to the database. And then, yeah, there's the web app, which is that interface that you sort of interact with. And that is some JavaScript stuff using sort of a framework for interaction, Alpine.js, like a templating engine, and some styling with Tailwind CSS. So yeah, basically that's kind of it. I can go through the code in some more detail, but enough because Jacob is here. We want to look specifically at this part here of these projects. Yeah, so we can go into that in a little bit more detail. But maybe to start, I'll just look at getting into the API first. I don't know how much, I mean, it's like 15 minutes left, so maybe we can just quickly jump into it. Let me just close this. Maybe that.
So when you build the package, you had to make all those connections to these other sources and programs, right? Like to the...
Yeah, so, well, yeah, like these connections are basically, this API is this Plumber API, and that exposes itself on the web. And then you can use this package HTTR, which basically does web requests from R to talk to that web package. And the same way, like this connection here is just another, it's just the web API that's allowing these things to talk to each other. And like, in a way, the database is basically like writing and reading from a file that's sort of like over a connection. Yeah. So these connections are there, but they're not really there. I don't know. They're sort of like, it's not like they're permanent connections or anything like that. This is just like in a particular location, and I just tell MonitauR where to look for the API. But I'll show you that right now. So this is the package. So it's on GitHub or whatever. But if I go to this, so this is the main monitor function. So this is the one you sort of call to get it to monitor script. And so here it has this API URL. And so this is actually where the API lives. So it's on this Heroku app. So MonitauR-API, HerokuApp.com is where the API lives. And so this is just saying like, okay, this is how you make that connection. Where's a good one? So yeah, this is like how it does the initialization. So it has these different private functions to do initialization. And so if I look at the API here, this is the function that basically is like how it says, I want to create a new job to initialize it. And so it uses the API URL here. And it has this /jobs endpoint, and it sends a post request, which is another type of HTTP request, and it uses HTTR to do that. It's kind of like curl or something. I don't know if you or wget on like the command line. And so it's just doing that from R. I think this even uses curl underneath. And so it's just saying, go to this URL and post this particular data. And so it's sending the job name and a token that you use to like group the jobs together. And it's getting back the ID for the job. But yeah, so basically it has that connection across there, and then does all these things. Nothing is really that exciting except for this part where it does the extract steps as futures. So basically a future is like a way of doing sort of asynchronous coding. So you can sort of delay the how code will run or when it will run. And so using futures, you're able to set up the code before it runs. So for example, I'm able to define where is it? Here. So this is a future here, and it's saying like this code will be run in the future at some point, but don't run it now. So I'm able to specify the token, a job ID, and a message so that this will run, this MonitauR script will run this code and print out the message step, which is like this step here, like step number 4. So I can set that code up dynamically. So I can create the code without actually executing it. So then I can wait and execute it later. And there's like different ways of doing this, but this was just sort of the way that I settled on that seemed to work the best. So yeah, you basically create all these different futures for each one of these comment steps. And then back in here, once you get the futures out, you basically combine them together. So you get all the expressions, so the actual code, and you combine it with these new future steps. And this is just like sorting them so they run in the correct order. And then you evaluate all those expressions. So it's like fairly straightforward, I guess. Like there's no real magic happening. But yeah, quickly go into the API.
Are features like a function or not really related?
Yeah, it's just an expression that has a delayed evaluation.
Okay. Yeah.
So there's a futures package.
What do you use invisible for again as well?
It's just so that when you return code and it's not captured, it doesn't print to the screen. So yeah, like basically if you just like run a function, it will show whatever. But this one will just say like, don't actually print it out unless you actually call print on it.
Okay.
Where's this one? Yeah. This is the future library. So for asynchronous evaluation of code. And so you can do stuff like, it has this like syntax, which I haven't really used or anything for it, but basically you can do parallel processing. And there's a bunch of cool things you can do with this library, which I have some, yeah, I don't know, it doesn't matter, but yeah, it's a cool library. But basically I'm just using it at the most basic level here just to be like, I just want to delay the evaluation of this expression. Yeah, cool. So let me open this other one quickly. so this is like a bit more of a messy project that hasn't been set up very well, but basically, so what happens with the Plumber project here, and there is, which one do I have? Yeah. So this is deployed on Heroku. And so Heroku is this, like I said, this sort of deployment management system. And so you're able to say, like, I want to deploy on this particular version of R. And when and it's hooked up to my Git repo. So every time I push to that repo, it loads that onto Heroku again and rebuilds the package and then deploys it to the internet. And so you'll get like this URL where you can access stuff. Basically, to start, it runs this initialization code. And so this just installs some packages, and it's sort of like I don't know, it's just installing these packages. It's not really important, but yeah, because I'm using Postgres, I have this R Postgres library, the database interface package, which just enables you to write SQL code in R to talk to a database. And then dbplyr is like dplyr, but you can read from a database. You can't do any writing, so it's kind of annoying actually. R doesn't seem to have like a useful what would you call it, a like an abstraction, an ORM, so an object relational mapper or something. So you can represent R database objects as R objects, which you can sort of do in one direction with dbplyr, but you can't do it the other way. So you can't like append to a database using like a dplyr expression. Sorry?
There's a package, SQL Lite R.
Yeah.
Can you append with that?
I have no idea. Yeah. So the problem with Heroku is that it doesn't have permanent disk storage. So every day, basically, they relaunch the servers. So with SQL Lite, you sort of have to write a file. And so using which is totally fine in a lot of cases, but using the database, it's sort of like a more permanent solution, I guess, because it's a separate like database server. But yeah, I'm not sure. As far as I can tell, it probably can do it. I mean, I'm sure it could do it. A lot of the time, it's just basically guessing what it should do. So writing to a database with something that's guessing a lot can always be tricky because it might get something wrong. But yeah, it really depends on how complicated your expressions are. Yeah, so basically to start with, in the Heroku environment, there's this database URL, and then I have this horrible code here, which I was just like sort of hacked together. I should probably do it better. But basically, this is like a long string that's like a URL that has a bunch of different variables in it, like the username, the password, the host, the port, the database name, etc., which is provided by Heroku. And so I use that to connect to the database. So I just get that from the environment and then extract the different values, because the database interface doesn't allow you to just specify a URL. You actually have to specify individual elements of that URL, which it then uses to rebuild the URL. So it's kind of dumb, but yeah. I use this pool library here, and that basically enables you to manage a pool of connections to a database. So yeah, like a database is kind of a server in a way. And so like with SQLite, I don't think it's kind of tricky, but you can end up with these like errors where if you try to read and write at the same time to a database, you can have these like transactional errors where like you might delete something with the first one, but it hasn't had time to update, and then you read at the same time. And so you get this sort of like almost like a race time sort of error where like one completes before the other. So to stop that, they just generally let you do one connection at a time. And so, but with like more like complicated databases like Postgres, you can establish a bunch of different connections, which enable you to basically have faster, so you can get multiple connections going at the same time. So you can have multiple servers reading from the same database to increase performance. But this is just sort of a connection management pool library. And so, yeah, creates that pool to manage the database. So it connects to the database and provides a pool which you then use to run all your commands and stuff. Then I just use these like tibbles to create the tables, basically. So I have these tables. So this is in the database. There's a jobs table and a steps table. So these are separated. I mean, this is all just like design. It doesn't have, you could do this any way you wanted, really. But basically, I split it up into 2 tables, and have in this table, I have a job ID which links to this jobs table, so that the steps, each job can have multiple steps, and that's sort of how this, or is it these sort of steps? Yeah. So each one of these is a step, and this sleep script is a job. And then, yeah, if they're not created, it then does this write to create these tables using the steps table and the jobs table. So it just creates the tables and then starts running the API. So this is the API here. Basically, it's the same sort of Plumber syntax. It has parameters for different things. So this one is, for example, to create a new job. And so it has a message parameter and a user token parameter, which is like how they're grouped together. And then it uses this write table command from the database interface. The pool, which is the connection to the database, says write to this particular table. And then it's saying append this new job to that one. And then I have this other function which uses the dbplyr sort of syntax to filter and extract a particular job ID, so that I can return the job ID once you create a new job, which is sort of that initialization step that we looked at in MonitauR. So yeah, there's a bunch of different functions here. Each one of them sort of do different things. This is important. So SQL has this like problem. So this is like poorly formatted SQL, but basically this is a SQL command here, and then I have these question marks, which basically saying to replace this variable here with a different variable that I supply in this function. And this is because you can do this thing called SQL injection, where people, because I'm doing this on the internet, someone can send like SQL code, and if you just insert it directly into a SQL like command string, people can escape that string and like do stuff like delete your entire database, basically. So it's very easy to give people access to all your data by just exposing an API that lets them add stuff to your SQL command. And so this command here basically is a way of escaping anything that they send. So whatever they send to you won't be able to edit your SQL command that you're using. So that's just like one little security thing that's in here. Not that there's a lot of security in this app. But yeah, basically that's it. There's a bunch of different things that, yeah, a bunch of different endpoints. I can show you the actual API. Sorry, 1 second.
I'm trying to run a MonitauR example script, or I just made one, but it's giving me an error. It's giving me error in this .path. This path used in an inappropriate fashion, and then it says No appropriate source call was found upon calling the stack, and active document in RStudio does not exist. I don't know what any of this means.
How did you run it?
I'll show you. Maybe I. Oh, okay. Wait, I can't. I'll just copy my code. I was just trying to do some system sleep, like a really, really basic script. Maybe I spelled something. I don't know.
Yeah. Okay. No, that's all right. I'll just show you this one thing and then we can have a look at that. So yeah, this is like the API. And so it does this automatic documentation generation thing. So these are all the endpoints. You can sort of see if I go to list all jobs, try it out, and I use the code token that I generated before, press execute, then this is sort of what is returned. So this is JSON, which is like each one of those scripts. And then like on here, this is what these three scripts, these three jobs are here. So this web app is basically sending this request here, like this curl request, but obviously using a different library to this endpoint / jobs. And that's sort of how you get, that's the interface between the API and the web app. And then, yeah, like this post one is like how the R app talks to the web API. But yeah, cool. That is about it, I guess. But yeah, it's 1 o'clock. We can look at your thing. It'd be good to figure that out. I'm sure there's plenty of bugs in it. I haven't really done any extensive. Actually, there's 0 testing. There's no testing for it. So
The first test.
yeah.
I just made a script. I didn't even save it yet, so maybe I have to save it. I'm not sure. I was sleeping still. So it just gives me this error message. I'm not sure about.
Do you have the, I wonder if it installed all the dependencies.
Yeah, it asked me to. I just installed it, and I said just to update everything.
Okay.
Yeah, I just said yes to all of them.
Oh, right. Yeah. So you will have to save it. Yeah. So there's
Okay.
a couple of things that are happening here. The problem is, so when that MonitauR script happens, you don't actually need, you don't run all your stuff. Yeah.
Yeah, cool.
So yeah. See how if you go to that link, it should open up. See the link in the title.r down the bottom?
Yeah.
Yeah. If you go to that link, then it should work with the web app. But so what you've done here by running it, it's a little bit of a hack, but when you run all the code, it's going to run it twice now, because the monitor code up there basically says run this. It takes the entire file.
Oh, so I don't need to.
Yeah, you don't need to run. All you need to do is run that first line, and that will run the entire script.
I see.
Yeah,
Okay.
which is why, yeah, at the end it's like rerunning it.
Gotcha.
Yeah.
Okay. So that would.
So just running that one. And so what you can do is just, normally what you do is just source the script or run it with R script.
With using, source of, okay.
Source it, yeah. So basically what it does is it exits the script once it finishes running that monitor thing. But since you run all the lines, it basically says, okay, run that one. And then once that line finishes, run the next line. So you actually, I mean, it's kind of like a weird bug. I don't know how you would stop that from happening, but it's just because you're sort of running it interactively when you like run line by line, as opposed to running as a script.
Makes sense. And is it, there's a job name part? Like if I put that
in.
in.
So if you specify the job name, that will give it a name, which is sort of what shows up in the script. And if you give it a token, so if you specify a token, that will like, so all the jobs will be grouped that way. Yeah.
Gotcha. Okay.
And then if you give it a name, then you can rename the script to whatever you want. Yeah.
Oh, does this say, yeah, okay.
That would just name it on the web app.
Okay, cool.
Did it come up on the
I just yeah, I think I got this last time. Unused argument.
is it I don't
Job.
know if that's something unused argument?
Anyway, just playing around with it.
Oh yeah. Yeah. Does it actually come up on the web app for you?
So it does if I put in the URL, but when I try and use the search bar, nothing comes up.
Sorry, go to can you show me the web app? So this
Yeah.
is another little like dumb quirk thing. I mean,
So like if I don't know if I search like maybe this is searching within.
yeah. So what's happening is that's searching within that token.
Okay.
Yeah.
So
So
if
what
I-
you can if you go to jobs, click that jobs tab there. And so now it's searching for the token. Yeah.
okay.
And then once it turns into I should probably change where the search bar is, but basically the same search bar
Can find
converts.
job.
It changes to a different one. Yeah.
That makes sense. Cool.
But yeah, and so I just had some comments about. So initially, I was just having all of the what do they call all of the jobs like grouped together just in one big pile, and so everyone could like access each other's jobs, and people were like very scared about that. So that's why I introduced like the token thing, but I didn't want it to be. I didn't want you to have to log in basically.
Yeah.
Because it was kind of annoying. I just wanted it to be like, it should just work. Like you just run it and it's able to work without having to like log in whenever. So you can do a more complicated thing where you specify the token. And so you might want to, make your own token and then specify that for every job that you run. So they're all grouped together. But
yeah, cool.
Yeah, I don't know. Yeah, it was just sort of like a dumb little side project.
That's awesome.
It's done now. So, well, not done, but at least it does something kind of.
My next question was going to be, does it work with R Markdown? Can you do it?
Oh man, yeah. I really wanted to work with R Markdown, but I'm not entirely sure how to do that. So there's this new R Markdown feature where they have like YAML parsing within the Markdown block.
Yeah, you can.
Maybe there's somehow you can hook into that. I went really deep into like R Markdown hooks and stuff like that to try and figure out a way to do it, but I really couldn't figure like
And why? Because it's its own program, R Markdown.
Yeah, basically because of the way that MonitauR works, it needs to extract those special comments from the code.
Oh.
And so you need a way to say like, this is the code that you want to extract it from. So short of like, and you don't want it to be complicated. Like it's all about the interface, right? So you don't want to have this complicated way where like, oh, I have to specify some code and then pass it into this other function to like, because it just becomes annoying. You just want it to be like, okay, I just like, whatever, add this chunk option that's like track or something, and then it will just automatically track it. So like there are ways to do it, which would be annoying. But yeah, it seems like an easy or elegant solution has eluded me. I have no idea. But you can also use this to do Shiny apps as well. So you can track Shiny apps. So you can use it for like a way of like real-time logging for Shiny apps. So you can just sort of set it up so that every time someone runs something in your app, then that's logged to this web app.
How long do the jobs stay around for? Like, do they?
It's forever. Yeah. So I just have this database set up. I'm just using a free database at the moment. It has 10,000 rows. If it got up to 10, I think there's like, I don't know, 100 jobs or something in at the moment. So if it got up to 10,000, maybe I'd consider like upgrading it to like a bigger size. But like the next size up is like 1 million or something. So
Shit.
Wow.
Yeah.
But yeah.
Nice.
That's
quite hardcore.
Well, yeah, I don't know. It's kind of funny because it's very common to do something like that in other programming languages. Like this is like a very sort of, you might even call it like an intro project to like web stuff. Like it's just that people don't do it in R. So it's sort of like an unusual thing. And like, yeah, like there are barely any, it's just like that Plumber library really that enables you to do web API development. And that's what Shiny uses like in the background, right? Like it uses Plumber to like, to do that sort of connection between the R code and the React front end. So there is some of this stuff being done, but yeah, not a lot of it.
Cool. Well,
Cool. Yeah. No worries. Yeah.
Yeah,
Now you
thank
guys
you.
can start doing talks again. Yay.
Yay. Now that
Yeah.
Jacob is here, you don't want to give a talk?
Yeah, you're trapped now. You got to give a talk. When are you? What are you working on at the moment? Some sort of database thing.
Well, it's not really. So at the moment, I'm like developing a pipeline for variant calling in like our novel organism. But it's like a big data set, and we're sort of in the process. So essentially, I've been trying to figure out what's the best way to go with like what collaborators we want to use for like data production, and then each and every step throughout the pipeline. And so we've sort of just decided what collaborator going with. So we're about to be bombarded with like, you know, sequencing data and metadata for like 8,000 samples. So yeah, I need to figure out how to manage that. And so, well, they didn't really put it on me, but like their idea of managing it or creating a database is like a directory full of, you know, like fucking CSV files. So
Yeah.
There's probably a better way to go about this. So I'm just on the side, whilst I'm trying to develop this pipeline, I thought I'd try and develop some sort of database that has some sort of web interface where, I don't know, they can upload shit and it's come to me. I'm not too sure.
Yeah. I wouldn't do it with R, to be honest. Yeah. Whatever I just did was a fucking nightmare to like really, it would be so much easier to do it in a language that's built for doing something like that. Like for example, Python has like a lot of really good interfaces and stuff for building out it has like framework. So like, you know, you can type like a init project and it will scaffold out a huge project for you that will have like, you know, administration features and like all these sort of web app features and stuff. Like there's a very cool library called Django, which is like it's what Instagram is built with, right? Like it's a very popular web framework. And so you can do basically, so that's kind of like a CRUD app, like create, update, read, delete. And so you that's like a very standard sort of way of creating apps to do that sort of thing. And they will like automatically hook into a database that you provide it and things like that. And then there is like all the way from very minimal writing, very like basically what you do with R, like very sort of customized code, to like some intermediates where you you have a bit more abstraction and things work a bit more nicely. And then right up to like Django is probably like the biggest sort of like top level framework, which obviously comes with all these overheads because you have to kind of understand the parts and how they go together. But it also like it's just out of the box like production level code.
I started looking at Python at the start, and the only deterrent was that I was thinking about, you know, most of it's going to be in SQL, like at a bottom layer, and like interacting with Python and SQL just seems so clunky.
Yeah, so don't do that. So what I was talking about before with the ORMs is that Python has ORMs. So it has this thing, a very, very nice library called SQL Alchemy. And so basically that enables you to use Python objects to communicate with your database. So you might have a Python object that's like a class that has like, you know, a shape. It's like a shape class and it has sides 4. And if you just edit the shape class and say like shape.sides equals 3, then that updates in the database. So you don't have to write SQL at all. Like I never write SQL. That's why I was like really sort of weirded out by doing it in R. So you so it has just a a super nice library, and there are heaps of these around. These are called object relational mappers, or ORM libraries, and these are ways of like mapping transactional commands like to a database, just to like objects in Python, or like heaps of other languages have these. But yeah, they're really useful and like just such a nice way to interact with database.
Okay, that's good to know.
Yeah, like doing it. Oh man, every time I write SQL, I get scared. Do you know this Bobby Tables, little Bobby Tables thing?
Oh, is that a little cartoon? You sent me one.
Yeah, oh yeah. Did I send it?
Yeah.
Exactly, yeah. So like it's basically some mom calls her kid like colon tilde drop tables or something. So like she, when they enter his name into like the school register, it like deletes all the other kids data, and she's like getting angry at them for not sanitizing their database input. And so this is just like a common problem where every time you start writing raw SQL that has stuff that comes from other people, you have to be very careful, because people, it's very easy to hack SQL code. Basically, you can just basically like, it's very easy to escape. Like if you have a string, you can just add another value, like a closing inverted comma, and then just write whatever you want. Like after that, okay, now I just want to read and return the database, and like, yeah. So it's very scary to write SQL that's going to be on the web. But yeah, if you're using an ORM, like that's all solved, because like you're never actually like directly manipulating the SQL string. Like that's all handled under the hood and escaped for you without having to worry about.
Okay, makes sense. It's funny, like I don't know, we put so much emphasis. I guess like it makes more sense with like data science, like at JCU, like it is kind of like why we use code, but like it seems so limited. Like it's, as soon as you get out of it, you're like, oh shit, like R sucks beyond data science. No,
yeah, man.
You know,
like
yeah,
even at data science, it kind of sucks. Let me go on my rant. I love shitting on R. So good.
Yeah, you were the guy who when I first met you, you were like, I'm going to convince everyone to not use R. And here you were making R packages. Thank you very much. So I was really convinced too here.
Yeah, well, you see, like in my process of learning R, I'm like figuring out how bad it is in all the corner cases where it's terrible. So I can be like, no, don't use it for this. Look, I tried really hard and it's terrible. It's
I try really hard.
They no, there's this like, I think it's because a bunch of statisticians made it and it's kind of hacked together. And so there's a lot of different issues with R where it's just sort of been piled on top of each other. And so you get these weird little quirks which make it annoying. And there's a lot of, I don't know if they have like a traditional like design ideas, goals and frameworks for like how they want, like with Python, there's like the PEP system, which is basically like a Python enhancement protocol or whatever. So it's like a way of deciding how new features and stuff are added to the language and how that fits in with like the greater idea of how Python's supposed to work. Whereas with R, people just seem to like chuck stuff in. They're like, oh yeah, this might work. And so they just, like that's how they have 4 different object-oriented systems like built within R, like all the different class systems and things like that. Yeah. But yeah, people still use it. I mean, it's growing in popularity as well, which is interesting.
I think it is easier, I would say. Like going from R to Python like was a struggle. Like I think because Python is maybe a little bit more nuanced, and then like in R, if you wrap your head around the tidyverse, you can then you're just dealing with data like statistical data or whatever. Like it's
that
super easy.
Yeah, that is one thing that R has, that functional sort of process where it can just sort of like data can just flow from function to function and out the other end. Whereas Python, maybe it has some functional aspects to it and stuff as well, but it's more object oriented. So it's not the greatest. R would still be the best data processing language. It's just that Python is the second best every language. It's like that everything. So that's sort of the thing. You get a generalist language versus like a specialized language. So yeah, like you were saying, if you want to go outside stats with R, there's just don't do it. It's like, yeah. But yeah, cool.
Interesting.
Like
Like now I have to learn. I need to learn Python. That's what you're telling me.
Yeah, well, I don't know. It sort of depends what you're doing. Like if you're not doing stuff outside of stats, why learn Python, right?
Yeah.
But it does give you like some skills for sure, where you can, because other people don't do it. Like for example, if you can write JavaScript in bioinformatics, people love that shit. Like people are all over web apps deployment and stuff nowadays, and like we'll give you a lot of money to be able to do that. So I think a lot of web developers don't really have the science background, but if you've got the science background and some web development, like a little bit of it, people really like that. They're in high demand because everyone wants to make it. I mean, it's easier now with Shiny apps and stuff like that, but
Yeah.
as you get to more complicated things, yeah.
And Java is with Python.
So Java
Or Java is its own.
Java.
language.
So they're two different things. So Java.
Oh my
is
God.
like
Choose one way, Tama.
well, I'm saying, yeah, Java. So Java is like a low level language like C. JavaScript is a high level language like Python that's written on the web. They're only called the same thing because because Java was popular. And so when they wrote JavaScript, they just called it that because the other one was popular. And they're not related at all. Like they're completely different languages. But JavaScript is what you write on the web. And so that's web programming. Java is like what applets and shit are written with. A lot of like old bioinformatics programs were written in Java. Some new ones are still written in that nowadays, but it's more of like a low level, high performance language. And then Python is like a generalist language, which you can sort of write these other things. So if you're writing Python, you could write web servers that then JavaScript stuff talks to. It's a whole thing. Yeah, I don't know. Like you can just being able to write Shiny apps, I think is probably a good thing. Like if you can do that, that's like a good way to be able to like publicize your code and be able to like share your code in a way and like
I feel like
provide
Shiny
a service.
is slow. They're just so, I don't know if I'm designing them wrong, but they just seem to me so much slower than other things. Like
yeah, that is a problem. Yeah, because a lot of it you don't get that low level customization that you would get with other things. It's for data scientists to be able to be like, okay, I quickly threw this thing together and chuck it out. But yeah, if you want to go like right onto the other end and build like huge, I don't know, multi-user platforms, then yeah,